Hi, I'm Mike Byrd. Today we're going to learn about how you can let T-SQL and SQL Server Agent determine the best fill factor for every index in your database. You've seen this slide before, but I'd like to relate a story. Well, something happened to me about 5 years ago. I was teaching a 8-hour T-SQL pre-con for SQL Saturday Dallas, and one of my attendees, about third hour into the session, asked, well, how can I be like you? And that got me to thinking about, well, past really has made me into what I am. I started off with the local users group, and then I started attending the past summits. And the past summits, not only are they great for networking, but they're also just great training and learning opportunities. And I also learned at the time the presenters being very passionate and having a zeal for SQL Server, and that's been passed on to me, very infectious in the way that worked. Then a little bit later, we started having SQL Saturdays, and because I was already giving presentations at the local users group, they just naturally flowed into SQL Saturdays, and I think I've done over 50 SQL Saturdays over the last 5 or 6 years. Anyway, past really has contributed to my growth in education, and I'm sure it can for you. Your feedback is very important to both PASS and myself. I'm trying something new today when I talk about the code. Yeah, I'm going to show results as I go with the code. And I'd really like your feedback on whether this is a suitable way to present code. In the past, when I presented code, it's always been a case where I'm almost going to sleep. So please let me know how I do today. I really appreciate that. I'm a senior database engineer. I work for myself. I consult for several companies in the greater Austin area. In the past, I was a rocket scientist. I got a master's from Purdue in rocket propulsion. I worked 2 years for General Dynamics Fort Worth as a propulsion engineer. That's, by the way, that's now Lockheed Fort Worth. And I also worked 3 years at the Air Force Rocket Propulsion Lab. Also, as a fighter pilot, instructor pilot, I flew T-37s, F-4s, and F-5s. I freelanced for PC Magazine for about 3 years doing tech writing. That's 9 years as a CTO for an insurance company. Got a new boss, and not long thereafter, we parted ways. And that got me back on the technical side, and I just love SQL Server. I love performance tuning, and I love teaching T-SQL. So that's me in a nutshell. I speak fluent Texan. I hope y'all understand me. I live about an hour from Austin to the west on Lake LBJ. In the upper right-hand picture, you see sunrise, and I do live in a village called Sunrise Beach. And we also have great moonrises, as you see in the lower right-hand side. Well, I'm going to let the cat out of the bag early. I'm going to give you the answer, and then you can listen to see how we got there. Frankly speaking, this has been an experimental method that I applied to a client's OLTP production system, produced an overall decrease in database wait times of 25 to 30%. That is not a trivial improvement. That is a great improvement. And I did this about 20 months ago, and it continues to have overall wait times for the database about 25% lower than it used to be, even though the database has grown and the applications have changed. Anyway, I'm hoping that this presentation will serve as an impetus to you to try this approach and help going forward. So we're going to talk about fill factor, what it is, how it's used, approach to dynamic fill factor calculation, short review of the code. It's not going to be short now. It's because I'm adding an extra presentation of the data as we go along. It's analysis, shortcomings, conclusions, and no demos, no live demos, but we do have data to show. If we look at a B-tree index, that's typically what it looks like in reality. Most times when somebody shows it, they show us a very symmetrical tree. In reality, it's always skewed to the left, and it fills in pages from left to right. When you actually start inserting data into an empty index, it starts with the first page, and usually an extent that's already in use somewhere. And remember, an extent has 8 pages, and each page is 8K. So as you fill up the page, it'll go to the next page, and the next page, and the next page. And so that's typically how a B-tree goes. And then after all the data is inserted, you get the pointers to the data, and you can have the root level at the top. And if necessary, you have intermediate levels to continue the pointers to point to each, so that you can get pointed to an individual row in each page. Fill factor is percent of fullness of the leaf pages of an index. If you have a fill factor of 100, then that means the page can take no more rows in that page. So what happens when a page cannot accommodate a new row? Well, we have good page splits and bad page splits. Yesterday I presented a 10-minute session on how bad are bad page splits, and it turned out that bad page splits can cost you about 0.033 milliseconds extra per page split, and an additional roughly 9 logical IOs for one page split. That logical IOs can make a significant effect on performance. The trick here is to find a fill factor that minimizes the bad page splits but doesn't result in an excessive storage penalty. So what are we talking about when we say page splits? Data can be added row by row to a page until it is full. In other words, you can't take another row. When there's not enough space within the page, a new page is added to the index. So fill factor is not an issue here on inserts. It's fill factor only comes into play after a rebuild, except, well, in 0.1% of the cases, Jeff Modem found an exception. And that's noted on SQLServerCentral.com. So looking at our B tree there, if we had a index that was monotonically increasing, like with an identity column, if we added a new row to the third block there on the right on the bottom, we'd get something like there, which is where the third row in the column is. And if we add that, then we can see that a new page is added, and the fourth block there and the extra row is added there. That's called a good page split. So what happens though if we have to insert a row in the middle of the sequence of rows? So say we, in the second page there from the left, we're talking about a full page, and we need to add another row because of the sequential nature of indexes and the way they're defined. Then something has to happen, and what happens is a new page is added, and the new page usually comes from a different extent, and now you have an out of order sequence of pages, and that causes extra IO. But not only do you get the extra IO from the extra or the not sequential set of pages, but half the data in the old page is moved to the new page, and the row is inserted in the appropriate page. Remember, it is in sequence. And sometimes if the leaf level, you also get a page split there. So sometimes you get the 2 for 1, which is not necessarily good, but it does keep everything in line. And notice there are pointers between each page at each level. So for the last 3+ years, I've been really diving into indexes and trying to determine their effect on performance and what I can do to improve performance. But nowhere have I found really a way to determine what the correct fill factor is for an index. There's some guidance out in Google world, but there's just not any definitive guidance. So what to do? A long time ago, somebody told me to give a good presentation that you really need to tell a story. So let's say once upon a time, Mike Byrd attended a session in Colorado Springs, and actually the first one I attended was in 2018. And at the speaker dinner, somebody asked me, he said, well, if you're so good with indexes, why don't you find out something about fill factor, give a presentation on that? So I left that conference cogitating about it, and I cogitated for over a year, and I'm still cogitating about it. From the SQL Saturday 8:30, which Colorado Springs again in April 2019, I attended 2 sessions by Jeff Modem titled Black Art's Index Maintenance, How the Best Practices Methods Are Silently Killing Performance. Both sessions were really outstanding. They can be downloaded in the link I show there. A Reader's Digest version of his presentations is contrary to the popular concept to reorganize at 10% and rebuild indexes at 30%. He showed in 2 presentations that the page splits cause tremendous performance degradations, and that you should probably rebuild your indexes at 1% fragmentation and not rebuild as often as people think you need to rebuild. So on the flight back home, I got thinking about everything he said and how fill factor also factors into index performance and maintenance. And so it got me to thinking about a brute force optimization technique I implemented way back when I worked at the Air Force Rocket Propulsion Laboratory. Yes, I already said I was once a rocket scientist, but I've always been a geek. It was a technique that involved tweaking various parameters, plus and minus percentages, and trying to discover the best tweaks for an optimal solution. In other words, trying to identify a performance factor, which in this case was fragmentation, and then tweaking fill factors to see what gave the minimum fragmentation. It was not always perfect in a multidimensional scenario because there are valleys in the multidimensions that the solution could drill down on, but it did give near optimal solutions that let you explore options. So approach I took, well, I took a technique similar to old Hogren's defrag script and modified accordingly. His script reorganizes at 10% fragmentation and rebuilds at 30% fragmentation. I was already using this script with no reorganize and rebuilds at 10%, so I wasn't far off from the 1% that Jeff had talked about. As I said, you need to be able to track performance fragmentation by fill factor for each index, and I didn't count heaps. I needed to build up a table that contained all the parametrics I need with the whole rebuild process for each rebuild, tweak and fill factor as necessary. And as I said, the performance parameter I picked was fragmentation, but I think there's a better one out there. I just don't know right now what it is. I have a friend that works for me that's been looking at Power BI and trying to correlate all the various performance information we've collected. But so far, neither one of us have just come down on what a better performance parameter might be other than fragmentation. There's a table. It has identity column ID and create date. It has table name, index name, current fragmentation, how many bad page splits, and page count and record count and so forth. And also down at the bottom, I have lag days. That's the number of days since the last rebuild. I have the fixed fill factor item, which is a term or a parameter I use to identify when I've actually fixed or set the fill factor for that particular index, and a del flag. And I also have, so I go out and get the top 20 indexes with the worst fragmentation and bad page splits. And I'll show you how I do that in just a second. From OLS defrag script, we can get average fragmentation percent from sys.dmdb index physical stats. That yields the average fragmentation percent, page count, row count. We can also go out to sysdmdb index operational stats, and that yields the leaf allocation count, non-leaf allocation count. And then from a script, an article I found by Jonathan Kaias from SQL Skills, he gave me a way to track bad page splits, and there's the link to that, which is incorporated in the script, which I'll show you in a few seconds. So there's my overall approach, and that's complex, and it's probably too complex or too much on the one slide to go. So we'll break it down into parts. And so let's go over and look at the setup script that defines the table, and here it is. And somewhere along the line, all this is in GitHub, but somewhere along the line, I dropped some columns from the agent index rebuild table, which is my history table, and I created a new one with new columns. So I created a migration script that allows you to either start, if you don't have an old agent index rebuilds table, it'll create a new one for you, or if it has an old one, it'll migrate the data, it'll create the new one, migrate the data, and rename it back again. And so there's the code for that, and then also the setup script, and here's the code from Jonathan Kaias to create the extended event that tracks bad page splits. So switching back again, let's look at a high-level approach, then we'll go back and look at the actual code. In my configure declare variables part of the flow chart, I have workday. I found, after monitoring data for a while, I found that probably shouldn't count the fragmentation on weekends. There still is an active 24/7 database, but on weekends, just the workload wasn't as heavy as it was on the weekdays. So I have a workday parameter, which is 0 when it's Saturday or Sunday, or 1 when it's elsewhere. And I use that for logic within some of my SQL queries. I go out and get the top 20 indexes by fragmentation or the top 20 bad page splits and alternate that daily, except on weekends. And you can see my two where clauses there where average fragmentation and percent is greater than 1.2. 1.0 just generated too much data, and so I pushed it slowly up to 1.2, and I'm happy with it there, at least for this particular database. On other days, I go out and get the bad page splits, which is, there's the where clause for that. And then I found when I started evaluating and going through index by index that I need to go back and, well, before I start the evaluation indexes, I need to go back and see if there's anything that's old that probably should be retweaked again. So I go back and find the oldest index in the table that has a fixed fill factor that's more than 90 days old, and I insert that row in there, readjusting a starting fill factor. Most of the time it's 100 fill factor, but frequently I'll show you the code that actually in other cases it doesn't drop it all the way back to 100. And then here's the workflow of it. So I declare a cursor for each index. And then first, right off the bat, I check to see if there's a minimum of 6 fill factor tweaks in the history table. If there are, I look to see if there is a minimum value of fragmentation that's not the last 2 rows in that temporary query that I've generated. If there is a minimum fill factor less than the 2 top rows, then I set the fixed fill factor and continue with rebuilding index as required. If I'm tweaking, after I do that, if I'm tweaking it, I calculate a new fill factor and use that to rebuild the index. I never allow the fill factor to drop below 70%, and that's just an arbitrary number I picked. So there, the last blue square near the bottom, I derive the SQL, rebuild, and I run that with dynamic SQL, and then I update the results from that from the history table. So let's now look at the SQL agent script rebuild indexes, and here's where I'm going to try my new session where I'm comparing data to the code at the same time. Okay, this is the script that's going to be put in SQL Agent, and I'll show you that in just a few minutes. But the name of the script is SQL Agent Script Rebuild Indexes.SQL, and it is in GitHub, and you should be able to pull it out fairly easy. What I want to do in this next few minutes is I have a variable in my list of variables at the top of the script where I have show processes. It's a bit and it's equal to 1. When it's 1, that means it's going to show where we are in the code, and it's going to give us output sort of like this. It's recorded in a bit log. So I have it set to 1. I also have show dynamic SQL commands equal to 1. I go through a lot of parameter definitions, but again, here's the workday that I talked about earlier, and it essentially is a divider between weekends and weekdays. And then I have a little bit of get together and whether we're doing enterprise version or not, and what kind of parameters I can rebuild with. The very first query where I go out and get the top 20 worst fragmentations or bad page splits is decided upon. The queries are almost identical except for the where clauses, but I have where the days equal to 1, I go out and I get down here in the where clause where the average fragmentation is 1.2, and then where the modulo is 0 or workday is 0, then I go out and get the bad page splits, which is further down here. Almost identical query, except here is where the bad page splits. Initially, I started with 50, then I dropped it to 20. I'm not sure what the best value is, and again, I'm kind of really I'd like to come upon a parameter for my performance parameter instead of just fragmentation, a combination of fragmentation and bad page splits, and maybe possibly page size, but I just haven't hit on the right combination yet. So what this query does, it goes out and gets all this top information, and I define up higher, our top word count is 20, and then the part of the script from Jonathan Chaos that gets the bad page splits is right there. And I go out and I say, give me everything that has, and for the odd days, an average fragmentation greater than 1.2, but is not already fixed. And then also for work days equal to 0, which is Saturday or Sunday, it'll bring back any index, whether that's in the table or not. And if it's and then when it does that, it just does fragmentation only on the weekends, or defrag on the weekends. So here's the query, and let's go back over here and see what for this particular day. So on October 20th, it brought back 10 indexes that met the criteria of, it's an even day, so it's bad page splits, and bad page splits greater than 20. And so you can see the bad page splits there. And current fragmentation, some of them are much lower, especially with your bigger tables. But you can see there's a significant number of bad page splits over here. The current fill factor is brought back. And page count and record count. And a lot of the other flags I don't bring back yet because they haven't been calculated or determined yet. So let's go back to the code and see what happens next. Okay, after I've gotten the bad page splits, I want to, since I do this on a 24-hour basis, I want to stop the extended event and then restart it so I can catch the next 24 hours of bad page splits. So I only capture bad page splits on the 24-hour capture window. So my T-SQL, dynamic SQL to calculate, stop and start the extended event. And then I go through and I want to try now to find the oldest index within the redo period, which is 90 days. It already has a fixed fill factor and added into agent index rebuilds, which is where I added the top 20 earlier, only this, in this case it's 10. And I go back through and calculate it. And if it does have a row count greater than 1, then I update it, and then I set the fill factor that I'm going to start working with. You can see here's my logic for calculating the fill factor I want to use. So when it's a index ID greater than 1, which means non-clustered index, I look to see if it's primary key, I set it to 100. If it's not a primary key and the great fixed fill factor value is 90, then I set it to 100. If it's 80, I set it back to 94. And if it's 70, I set it back to 90. So it's not necessarily always having to go back to 100 to restart the whole initial tweaking process again. And then I store all that information and put it back in the history table right there. And so in this, you can see I stopped and started there. And this is, it picked up a value of index of IDX file client folder ID, which is, you can see the current fragmentation, and everything's there in the temp 2, so it adds it back in. Now let's go back over here and look and see what's going on when I define the cursor. So now I have a total of 10 rows, and I declare the cursor, and I actually go out and calculate lag date, which is this elaborate subquery right here. And I use that lag date if I hit an index that I've recently calculated a new tweak fill factor, then I probably want to do a slightly different logic than if I have a lag date that's greater in a week or two. And I'll show you that down here below. So you can see here's my show process steps. So now I just go back through and give you what I define as a cursor. So if we come back over here, you can see here's my cursor definition. Here's the fill factors that were in existence when I brought them in. And then if I come over at the lag dates, you can see there, in this case, they're all small lag dates. So I'm repeating myself quite a bit on the bad page splits. And then I go through and I set up the cursor such that I do one index at a time. And that's what there. So I open my work cursor, I find it up above, I fetch all these parameters into it. And then I reset some parameters to start for each loop at a time to go through there. And then I have just to see where I'm going. We come down here, and there's my work cursor parameters, ID, and object ID, fill factor, and object name, and so forth. So then, this is where I do the last 6 rebuilds to see whether or not I need to fix the fill factor. And when I first presented this at SQL Saturday Baton Rouge in 2019, I asked the audience, and we had a nice interactive discussion on, well, how should I set the minimum fill factor? And they said, pretty well everybody agreed we should go with a minimum of 6 tweaks but we shouldn't count the last two. In other words, once it's reached a minimum, keep tweaking a little bit more to ensure that is the minimum. And I'll show you some example of data of that in a second. So we work through that and calculate the min and max and find out whether or not the index needs to be set or not. The fill factor needs to be set, and that's where I set it. And then I also select a new fill filter set. Now, all this is only applicable if we have 6 tweaks previously to this or not. So let's come back over here and I check and I don't have any for this particular case. So a little bit further down, you'll see I do have a case. Then we come back up in the code. And now if the table's partition, I've already, just as I've thrown out heaps, I've thrown out partition tables, mainly because, and you'll see this at the end of my conclusions, is that Microsoft just hasn't got their act together. In my mind, every partition ought to have its own fill factor so that the older partitions can have a fill factor of 100 and newer partitions can be tweaked as needed, but they don't right now. So once you set a fill factor for a partition table, it's applicable to all the partitions, not just the one. So then I have the logic for determinant. And so if it's a redo and it's 100, I catch the redo index. And if it's not, if it's still 1 and the lag date is null, then the 100 index again. Anyway, I go down through and depending on lag dates and whether it's non-clustered to clustered, I reset. In one case, if the lag date is less than 14, I subtract 2 because it's a fairly active index in my tweaking system. And if it's the lag date is greater than 14, I set it to 1, -1, and so forth. And then I never let it get back below 70 as I showed. And so if we look down here, we have here, and the fill factor is 98 for this particular case. The fixed fill factor is null, so that means it's tweaking in partition day and work day and so forth. And then here's the command, the dynamic SQL to rebuild, and I have with a fill factor of 98 as I calculated up earlier. For a long time, especially this last summer, I was having all kinds of issues with deadlocks, and it turned out it was an always-on issue that I'm going to document one of these days. I just haven't gotten around to document it. But so I have retries on running the dynamic SQL, the rebuild process itself. And so then at the end, when I've completed the cursor and all the work I've done on it and saved it, coming back over here, show the process steps, and there's the SQL. And then all this logic may not be necessary anymore, but it's there and it doesn't hurt anything, and it's really not taking up much time. I go back and update the agent index rebuilds table, which is our history table with the index rebuild duration in seconds, what the new fragmentation is, what the lag dates were, because I hadn't set it yet, and what the fill factor that I used was. And then I show that again right there. And then I fetch in the next cursor parameters, and this end here is where the cursor starts. So let's go back through and look through what else fallen. Okay, so for the second index that we're looking at, this one right here, we get the parameters, and you can see this one was 1, 2, 3, 4, 5. 5 cases of fragmentation, but it's not 6 yet. So we're not going to stop it yet. And you can see the row count's 5. So the fixed fill factor is still null. We haven't done anything with it. It's now running a new fill factor of 92. There's a command to do it. And if we come over, you can see it's fill factor 92. Completes the job. Now we go to the third index that's in the process. Now you can see we have row count of 7. And if we look at the current fragmentation, 1.3, 1.23, 224, 1.28, 0.5, and then there's 2 values after that that are greater than that. So this is our min value right here with a fill factor of 92. So now I use the logic built in the code to set the new fill factor, and I set it, let's see, where is that? I set the fixed fill factor 92, and that, by setting it that, it means it's not going to be looked at again, that particular index, for another 90 days. Check for partition, check for new fill factor. Here's my rebuild here, and again with fill factor equal to 92, and only one retry, and there's the end of that cursor. So again, looking again at the next index, nothing's really spectacular here in the way of what's going on. And again, there's no tweaks. Same thing here, got the rebuild again. And you can see here, there's only 2 previous perturbs for this particular here, where we're on starting cursor 6. And that's the way this code works. Then at the very end of the code, because I wanted to see what was going on, and I was, especially this summer when I was having so many issues with deadlocks, that I sent myself an email, and I'll show you what that email format looks like in just a second. So that's the end of this section here, and let's switch back to PowerPoint. Okay, here is another way of looking at the fixing the fill factor. We have 2 cases here. The top one, we have 7 lines, but the first 6 were used to determine on fixing the fill factor. And you can see the 4th one down with a fill factor of 94, we had a fragmentation of 0.466. And then we had subsequent, the 5th and 6th lines, they were greater than 0.466. So looking at the whole picture, what happened here is when we got to the 7th time where it was going to perturb, it already had 6, it already had one with a minimum fill factor. And so it, now with the minimum at 94, it sets the fill factor at 94. It fixes the fill factor at 94. Up until then, the values for those first 6 cases, the fixed value or column there was all null. So once we fix a fill factor, then we set everything equal to 94, or in this case 94, and del flag the previous 6, so that going forward we'll only use what we actually have there as it is set. In the second case, we have more than 6, and the same instance applies here. So we have 1, 2, 3, 4, 5, 6. So we have 7 perturbations that drop down finally to a fragmentation of 1.70. Then the 8th and 9th jump up from 1.75 to 2.179. And the same criteria applies there. We now set del flag all the previous 9, and we set and since the minimum fragmentation was at 88, we set the fill factor 98, and then we set everything equal to 98 over on the fixed column. And again, prior to the last step there, all the values in the fixed column were null. And we set then everything del flag, as I said earlier, to 1. Notice here that in both cases, the redo flag, both these were cases where we hit the 90-day period and it restarted the whole tweaking process over again. This is what an example, and I have a couple of examples of my nightly email report. As you can see, even though we're picking top 20, not necessarily now, the system is pretty well stabilized where I'm usually not getting 20 unless it's a weekend where I'm just doing defrag only. But in this case, we had a clustered index with 4916 bad page splits, and it fixed it at 98%. Notice the duration there is 976 seconds, which is almost 15 minutes, a big table there. Then we also had a fix on a non-clustered index, and it fixed it at 94. All the rest were still being tweaked, and even look down at PK, the bottom one, PK underscore file attribute, we had a duration of 1610, which is not quite 30 minutes. So anyway, so there we are, and that's an example of the night report. And then under actions, if it's an F, that means it did the fill factor tweaking. If I have an R, which is usually on weekends, that means it rebuilt the index, or if it's a partition index, it would have an R there. And if it found an error and couldn't resolve the error, you'd have an E in there. So happiness for me every night's getting an email with all F's and or R's on the weekends. Again, here's another nightly report, and this is on a odd day, and so we don't have a lot of bad page splits, but we do have fragmentations that are greater than 1.2. Notice there's more here. Still not 20. Again, the system stabilized and running a lot better, or running fairly nice. And notice over in the durations, all the durations are real small. There's smaller tables tend to fragment easier, I guess, because there may not be enough rows to, or there's not enough rows for you have a half full page that it may now cause the fragmentation value to go up. But anyway, you can see all these are varying. There was two that got fixed on this night rerun. One was the IDX alert subject, and the other was the IX _ alert _ user ID. One was at 100. That's unusual to see a non-clustered at 100, but it is. And the other is a non-clustered index that fixed itself at 92. Typically on a weekend, we do get all 20 values because there's lots of indexes that one we're not even touching, or two they're in that 90-day period that's fixed. And so you can see down in the middle, IX _ file _ name ran for 2760. I guess that's roughly about 40 minutes. And then IX file section is almost 3 minutes there for it. Or no, 30 minutes for it. Anyway, in any case, this is typical of a nightly weekend email report. As I said earlier, I set this up as a SQL Agent Job. The script that we've been talking about goes over in the job step properties, and I just inserted there just as I've shown there. I blacked out some of these things just to protect the client to some extent. Anyway, it goes there, and then for this particular client, their slowest use time is from 7 to 10 p.m. And so this particular run runs at 7:47, and typically runs anywhere from 5 minutes to 3 hours, depending on how many indexes we're rebuilding and the size of the indexes we're rebuilding. So initially I set up a SQL Agent Job nightly to collect data. And when I first started, I wasn't doing any tweaking. I was just collecting data to see what was happening. But I was varying fill factor, but I wasn't setting anything. As the data was collected, I added new columns to the history table and revised logic to determine our fix of fill factor for each index code identified as needing a tweaking. After watching for a while and watching patterns emerge and the way the data started skewing, and we had new app changes and the database was evolving, I decided on a period of time that we probably needed to go back and relook at the indexes, as I've said earlier, and I've just arbitrarily picked 90 days to go back and look at them. Excuse me. I ran data collection on a very active client OLTV database. When I first started, there were 225 gigabytes of real data that did not include sprox, views, or anything else. It was actual data. 249 tables in the database, 694 indexes in it, run 24/7. In the first 90-day period, I only saw 164 indexes that were touched and tweaked to some extent, not necessarily to completion, but they were tweaked and recorded. And actually, what really surprised me is I saw no real performance hits while I was running the fill factor script, mainly because of the online option for enterprise version. Of course, we've talked about it. There are different types of indexes that we encountered. They're clustered indexes, and they're based on sequential increase. An identity column is a great example of that. And we also have clustered indexes based on a parent table plus a primary key, which is usually identity column. And for this particular client, an example of that would be our file attribute table, where we had our clustered index defined as file ID, and then file attribute ID, where file attribute ID was the identity column within the file attribute table. And then non-clustered indexes are usually based on non-PK column. So what does that look like? Well, you know, a picture's worth 1,000 words, is looking to see what's going on here. In this particular case, we started off with a clustered index. We started at 100% fill factor, dropped it all the way down to 95. We had 6 cases there, but we had 6 cases, and the minimum was where we first started at 100. So, in my mind, for this particular clustered index, based on an agility column, 100 was the right number to arrive at, and it did. Okay, we had another for a non-clustered index, and notice the peaks and ups and downs here, and that's what part that makes me unsure that the fragmentation should be the only factor we're considering when we're varying the fill factor. And that depends, different types of business loads occurs on different days. And so anyway, long story short is that we have 1, 2, 3, 4, 5, 6, 7, 8 cases here, and it still hasn't converged because you can see the minimum value is there at 86. So probably the min fill factor is going to be either 86 or lower. Here's another case where we started off at 98, varied around. You can see the ups and downs, but we eventually got down to 86. And don't look at the last point. 86 occurs earlier, and pick that as a min value because there's 2 values following that are larger. And then when we recalculated again on the day we recalculated, it actually ended up with a lower value than what started as far as fragmentation went. The bad news is you can point fingers at me. I did not have good benchmarks for database performance, and that's, I'm sorry about that. That's just the way it was. But this was a typical screenshot from Database Performance Analyzer from SolarWinds, and it's taken late February 2019. And this was typical performance during the day. I use DPA to see what's going on, and it gives me a good window for 10-minute periods within the last hour. And this is the free version also. And you can see that typical performance was somewhere between 300 to 500 seconds per every 10 minutes. And with 32 processors, that's not a bad case of performance there. It sounds high, but not when you have that many processors available. And then I did another screenshot. I know it's not the same time, but it's typical performance during the day. And notice now I'm varying from about 200 up to 350. And there are occasional spikes above the 350, but for the most part, average performance during the day is somewhere around the 300 mark, whereas before it was up higher, closer to 400 or 500. So that kind of comes out and says, well, we're averaging around 300 seconds per 10-minute period. And that shows really a tremendous drop in overall database wait times. And to me, wait times are the most important thing when you're looking at for what is a user seeing from his end. Their business has evolved, and as I said earlier, we're getting different data SKUs as it's evolving and different ways, means of access, and new stored procedures and so forth. But again, as I said, the spikes are our spikes greater than 300, but the average still remains about 300 seconds per 10-minute period. So, wow, database wait times dropping 25, 30%. And you don't know how elated I was when I first saw that. And why? Well, with decreased fragmentation or less page breadths to wade through for I/O range searches. And also with improved fill factor, there are less bad page splits because the cost of a page split can be significant, as we showed in yesterday's 10-minute brief on bad page splits. But when you get a new page that has to be identified and it's bad, you gotta move the data, half the data from the old page to the new page, insert the data, and then maybe even there might be changes up above in the pointers in the intermediate level. And so all this is logged to the transaction log, and it can cost you, and we saw in yesterday's briefing, that it can cost you 9 additional logical IOs per bad page split. Okay, requirements to use this. Need to have SQL Server 2012 and above. In fact, all my performance and everything you've seen today was run on SQL Server 2012. I'm having a hard time getting my client to upgrade to 2019. He wants to, but he just doesn't want to spend the money. And the reason enterprise version is recommended because it's the online option. You can use standard edition, but you have to be wary of schema locks, especially during these index rebuilds. I highly recommend data compression equal row all the time. I've used it now for 10+ years, and it just works beautifully. You already have an enterprise version, and you also have it in standard edition with SQL Server 2016, Service Pack 2, and later. Shortcomings. Okay, so what's going on all this time? Well, the varying business loads during each business day can and will affect the fragmentation value. I mean, the workload on Mondays may be different than the workload on Wednesdays, which may be different than workload on Fridays. And then that may vary depending on the week from day to day too. So I'm not sure fragmentation is the perfect value to use for my performance evaluator, but it is one that seems to work and it seems to help. Okay, I did add code to only rebuild indexes on the weekends because of the fact that the weekends, the workload is not as high. What I really would like, and I've been working on, and again, I said I have a guy where I'm working with, a Power BI expert we're trying to come up with some type of relationship between fragmentation, bad page splits, and index page count for a better performance parameter. We just haven't found it. I haven't found anything that kind of meshes together as nicely as what we already have. Wish list. Add additional code for multiple databases on the same server. My history table has some of the columns already built in. I just haven't done it yet. You may want to have a separate database then for your history table. And again, I just said this, really like that mathematical relationship. It's just something that I feel that I just haven't quite got all the way to the top of the ladder yet. And I said this earlier, and I don't understand why Microsoft hasn't made a change there. Anyway, the current fill factor approach is not implemented for partition indexes. It will pick them out, it will select them, but it won't tweak them. It'll just rebuild them and essentially defrag them as they're encountered. It'd be nice if they could have a fill factor for each data partition, and my code would work with that. It's just right now it can't because right now you're fixed to one fill factor for the entire partition table. Yuck. And build in additional features as suggested by the community. I've gotten some input from previous briefings, and I'm still looking forward for lots and lots of constructive criticism and critique. Really would like somebody to do some additional performance improvements. For this particular database, we saw the 25–30% improvement in wait times. However, I'm not sure how this would work on other databases, and I'd love to see how it works on data warehouses too. Need a better way of monitoring the what's going on within agent index rebuilds, the nightly jobs. I've created my email report that's kind of halfway there, but it'd really be nice if I had a dashboard to look at, or as a DBA, you had a dashboard to look at. And I'm looking for anybody out there who wants to volunteer to do a dashboard. And a big question, are nightly rebuilds necessary? Jeff Modem and Brent Ozark don't think so. In my humble opinion, yes, but only to establish the fill factor. And again, right now, all we do, we only defrag on weekends, Saturdays and Sundays. And I've seen anywhere from 5 minute to 3 hour runtimes for this script, but I've seen really no effect on production query performance, even though it is running during a period of low activity. Ongoing work, what am I still doing? Well, I'm still monitoring and analyzing. The script's been extremely stable the last 2+ months. The only changes I've really made have been to add additional documentation within the scripts. You may need to limit the number of large tables for night evaluation, especially if you have a lot of large tables with lots of bad page splits. You may want to limit it. And I've got an idea for code for that. I just haven't implemented it yet. And the script, as I said, runs 2 minutes, almost 3 hours. So what do we have? Where are we right now? This whole idea started as a proof of concept. But like any proof of concept, to get it to work, I had to put it in a production environment, and that's what happened. Initially, there were some bugs in the code as I deployed it, but I was watching it and watching it almost nightly, and those bugs have gone away now. I think there's a potential for tremendous performance benefits. It does demonstrate that effective automatic determination of fill factor is possible. And again, it's been around for 20 months. So question to you, why aren't you using this? I really think that it needs to be explored more, and I think it can really help everybody from a performance viewpoint. This concept has been copyrighted, and I've given it to the SQL Server community, and it's yours, and as long as it's not put into private software, I'm very happy with continuing with the way we're handling it right now. So can you not afford to take a 25% drop in database wait times? Again, the scripts are available at GitHub under my name and Byrd TX. And then there's only one project underneath that, and that's the SQL Server fill factor determination. I thank you much. I hope you've gotten some out of this briefing. I have, just in presenting it. So I hope y'all have a good day and a good rest of the year. Bye.